Assalamualaikum everyone. Welcome to our presentation. I am Marjan Akhtar Apon and my co-presenter is Salma Akhtar. Today we are presenting again Generative Adversarial Networks. This is our course outline. Our course code is CC4355 and our course title is Artificial Intelligence and Expert Systems, and we are presenting this to our honorable teacher Amrita Harun Masood sir. Now we will see Introduction to GANs. Generative adversarial networks are a powerful class of neural networks that are used for an unsupervised learning. We divided generative adversarial networks into three parts. These are generative, adversarial, and network. Generative refers to a model which describes how data is generated in terms of a probabilistic model. In the context of GANs, adversarial refers to a competition between the generator and the discriminator. By using discriminator, adversarial compared generative result with the actual images. Network refers to a deep neural network, which is a type of artificial intelligence algorithm. It processes complex data patterns and used for training for the generator and the discriminator. After that, our gains are made up of two neural networks, a discriminator and a generator. A generator takes random noise as input and converts it into complex data samples like text or images. There is a term generator loss function. Generator minimizes the generator loss function to produce synthetic samples that are realistic enough to fool the discriminator. A discriminator is an artificial neural network which differentiate between generator and actual input. There is also a term for discriminator which is in discriminator loss. Discriminator reduce discriminator loss by accurately identifying artificial and real samples. Now we will see how GANs work. Here we added a diagram. It represents the workflow of GANs. The process starts with the latent random variables. This is passed to the generator, and generator takes these random variables as input and generated fake samples. Then our discriminator takes two things as an input: real data samples, which is from the training datasets, and the generated fake samples, which is produced by the generator. Then discriminator produce an outputs in a probabilistic score between 0 and 1. 0 indicates fake and 1 indicates real. For better understanding, now we will see a real life scenario. This is a famous example for generative adversarial network, which is thief and police example. Suppose I am a skilled thief and I am specialized in making counterfeit money. Counterfeit money means fake currency. So, my goal is to create fake currency that banks and anyone can't tell the difference. Now I start with blank piece of paper and I use my expert team to design and print fake notes. And on the other hand, Salma is a trained police officer who is responsible for detecting counterfeit money. At first, Salma might not be very good at spotting fake bills. That's why a lot of counterfeit money slip. Then, day by day, she gains more experience and studies real and fake currency. Now, she becomes an expert at identifying fake money. But this is not good for me because I am the thief. So I work hard to improve my counterfeiting skills and create counterfeit money that's almost identical to real money. On the other hand, the police officer becomes more skilled at detecting counterfeit bills, and this process is continuously ongoing. So basically, GAN employs a dynamic interplay between a generator and a discriminator, with both components learning and improving over time. The ultimate goal is for the generator to create images that are so realistic that the discriminator struggles to differentiate between them and real images. Now, we will see some applications of GANs. The first one is image to image translation. Image to image translation is a technique where an input image is transformed into another image while maintaining its key features. Here, these photos represents daytime cityscapes to nighttime cityscapes. And in these pictures, the input pictures are paintings which are converted into photographs. Then the other application is text to image generation. Here, we will given a text as an input and GANs will produce a realistic picture from the description of the given text. In this picture, we given this text as an input and these photographs are generated by the GANs. As similar, we given this text as an input and GANs produce these pictures as an output. Then semantic image to photo translation. A semantic image is an abstract representation and it represented by a unique color or label. As you can see, this image is representing different colors for different things. This is given as an input and GANs convert this into a realistic visuals by predicting textures, lighting and details. Another application is photos to emojis. Here, we provide the realistic photos as input and GANs will transform these photos into emojis by preserving elements like shape, expression, or identity. The last one is 3D object generation. GANs are used to create 3D models or objects. We provide some objects as input and GANs generates three-dimensional representations of objects with realistic shapes and textures. So I am done with my part. Now Salma Akhtar will present the rest of the topics. Thank you.
Thank you, Marjahan Akhtar Apon. I'm going to explain different types of GAN. First is vanilla GAN. It is a basic GAN with two parts, a generator and a discriminator. Here is the example generating fake handwritten digit. The generator creates random digit like 0, 1, 2 as image and discriminator tries to guess if they are real or fake. They learn from each other to get better. Style GAN. It creates high quality images with control over things like style, pose, and lighting by turning random noise into detailed feature. The first picture shows a progression from a simple sketch to a more detailed stylized portrait and finally to a photorealistic anime style portrait. Next, okay. Cycle GAN. It changes images from one style to another without needing paired images. It uses two generator and two discriminator. It can turn a horse into a zebra and can turn the zebra back into horse again. Super resolution GAN. It improves low resolution images to high resolution, making them clearer. The generator turns a blurry image into a clear one. and the discriminator checks if it looks like a real high resolution image. Next, similar models. Variational autoencoders. Both GANs and variational autoencoders are generative models that learn to approximate a data distribution and generate new similar samples. Flow based models. Both GANs and flow based models aim to generate realistic data by learning the underlying data distribution. Diffusion models. Both GANs and diffusion models are generative models designed to create realistic data by learning complex data distribution. Next, there are some advantages of GANs like synthetic data generation. GANs can create completely new and fake data that looks real based on the pattern they learn from actual data. Imagine you have a few pictures of cats and you want more picture for your project. A GAN can generate new realistic looking cat images that don't exist in real life. High quality results. GANs can produce extremely realistic results that are hard to distinguish from real data. When GANs create fake human faces for AI avatars, they look so lifelike that people can't tell they are generated by a computer. Unsupervised learning. GANs don't need labeled data like tag or categories to learn. They can figure out patterns in the data on their own. If you give a GAN a bunch of landscape photos without saying what's in them, it can still learn to create new landscapes. Versatility. GANs can be used for many different tasks beyond just generating images, like text to image synthesis, image to image translation, anomaly detection, and data augmentation. Next, there are some disadvantages of GAN. GANs are hard to train and may fail to work properly or become stuck in certain patterns. They need a lot of computing power and time, especially with large dataset or high resolution images. They can make results that are too similar to the training data. If the training data has biases, the GAN can create biased or unfair results. Thank you.
Thank you everyone for hearing our presentation. If anyone have any question, you are welcome to ask. Thank you.